So let's kind of take stock of where we are. So I think, did everybody get one of these guys? Whoops. You could do it. I have faith in you. There you go. Come back. You can do it. Come back. All right. Does anyone need one of these? Yes. Okay. Is everybody else good? Okay. If I'm a student in this class, when I'm doing my homework that's asking me to verify identities, I'm having this sucker sit next to me. The two things we don't have to worry about yet, they're going to be section 10.1, 10.2, or these two. But I figure we know most of these, so I wanted to give this to you a little early because it's useful. Right? So just these guys, don't worry about them yet. You can stare at them if you want to. Don't worry about it. Everything else up here, above this black line, you must know. I'm going to assume you know. I like that point. Everything below the black line, if I ask you a question about it, I'm going to give it to you. And then it's just a plug and chug thing. If you see it in the homework, it's a plug and chug thing. The section 9.4 I made extra credit is about these two. This is actually from chapter 10, so it really doesn't matter yet. This is freaky as shit. This is very not often used. So that's why it's down here. You don't have to worry about memorizing these guys. But I just put them here so it's a quick reference. So if you're doing homework, you can just plug and chug into the appropriate one. Is everybody with me? And here's everything we just talked about with the inverse stuff. Yeah. Okay.
How about number 4 in line 1?
Yeah. I think I was there. Shoot. All right, 4, this guy. Oh, okay. This is what I keep saying. You don't have to memorize as much. What do I do to this to get either one of the other two Pythagorean identities? Yeah, I either divide by sine squared, everything. To divide by sine squared, I get 1 plus cotangent squared equals cosecant squared. And if I divide by cosine squared, I get tangent squared plus 1 equals secant squared. So those are the 3 Pythagorean identities. You only have to memorize one if you want to, because you can build the other 2 from it. That's what I did. I basically have them memorized now just because I've used them a lot. So they're stuck in my head no matter what I tried to do. But when I was a student, I just memorized sine squared, cosine squared, and then I just made the other ones when I needed them. So it's up to you. You guys all with me? Okay. The ones we most, is that all right, Mike? I mean, it's got to be all right. That's basically the problem. The ones we did most recently were these, and they led to these. These came from these. So again, this is a situation where you don't even have to necessarily memorize these. You can memorize this and then use it to build what you need later. Or you just straight up memorize these. The nice thing again is cosine's still an asshole. It said, I'm going to take the plus sign, you take the minus sign, And look, cosine's an asshole. I'm going to be in both of these. No. So if that helps, great. If it doesn't, come up with a better thing for you to memorize. Okay. Maybe. Is that all right?
So you would move over, for example, to the side. You move over the 2 sign to the other side of 1, and then you divide by 2, and then you...
So here, yeah.
And then you square them both.
Yeah. Like here, if I add 1, that's 1 plus, and then I divide by 2, and then I take the square root. Yeah.
So 2 cosine squared minus 1.
That's exactly what I was just talking about, yes.
Yeah.
Yeah, okay.
And you add 1 to the other side. You divide by 2.
Yeah, that's exactly what we did to develop that formula, yes. We did that. Okay.
So theta... Alright. How to get it. I'll figure it out.
So here's the thing. here's what we talked about, just to do this again. So if I start from here, this guy, if I want to solve for cosine, I would add 1,
Oh, yeah.
divide by 2, let me do it like this one. And then I would take a square root.
Oh, yeah. Gotcha.
Now here's the trick. Let me write this the way it's written. Here's the trick. This formula says whatever angle this is, this has to be, if I put 11 here, I've got to put what here? Whatever angle this is double that, yes? So if I put theta over 2, what's twice theta over 2? Theta. So now I've made it explicitly, and again, there's no real reason that you have to do this,
That's right.
but we wanted it to be very obvious, a half angle identity.
That's what I was confused.
Okay, but does that make sense? This formula says whatever angle you put here inside that cosine has to be double
Oh, yeah. then
what you
go
put
down.
there. That's all that formula says. I could put whatever the shit I want to here. I could put 4W here. If I put 4W here, what's got to go inside this cosine? If that's 4W, what's got to go inside this cosine? 8W, holy shit. So whatever I put in the first dude, it's going to be double that in the second dude. So to explicitly make a half angle formula, we put a theta over 2 here, this half angle, and then twice that is what goes here. So to be really honest with you, I always found that to be kind of goofy. I'm like, what the hell? But they wanted to make an explicit half angle formula. This is obviously a half angle formula. Same way that this is a double angle formula. That's crazy sauce. But all this formula says is, whatever angle this is, that one's got to be half of it. That's all that formula says. Okay, maybe. So if I wanted to know cosine of, I can't remember if we did this, 105 degrees.
Split it up.
No?
No?
Why does 105 degrees suck? If I ask you to do this without a calculator, and I will, why does 105 degrees suck as a choice? It's not one of the ones we know, right? It's not 30, 60, 90. It doesn't have a reference. The reference, what would the reference angle be for that? 75 degrees. Say yes. Is that one we know? No. Damn it. But what's double 105? 210. What's the reference angle for 210? 30. And we know that shit, don't we? Okay. So if I use this formula, isn't this angle that I'm working with half of an angle that I know something about? Therefore, I can use this. Now, what quadrant is this in?
Third. Or 210.
Second quadrant. What's cosine going to be? Positive or negative?
Negative.
So that's a choice we have to make.
Oh, yeah, that's in the second.
But this is going to be double this. According to the formula. Whatever this angle is, I'm going to put double it right there. If you think backwards, whatever angle this is, that's got to be half of it. Cosine of 210, like Noah just said, has a reference angle of who to what? What's the reference angle for 210? 30. So you can always draw a really quick little sketch. That's 30 degrees. So what is the cosine of 210? It's going to be the reference angle of 30. Is it going to be positive or negative?
Negative.
Negative because I'm back here, yes? And what's the cosine of 30?
Yeah.
Right, 3 over 2. Cosine likes x. 30 is close to x.
Oh.
Yes. I prefer what I'm saying there to just straight up memorization. If you prefer straight up memorization, beautiful. I just prefer, think if we're saying 30 is close to x, cosine likes it, it's bigger. Bam, right? Okay. Now here's where some of you guys are going to stop, and I don't blame you because you feel like you've done a lot. Yeah. But what kind of screams at me that I need to do at least one more thing here?
Get rid of the 2.
I got to get rid of this internal fraction, right? So what would I do to top and bottom to kill that fraction?
Multiplied by
2. So I'll get 2 minus square root of 3 over 4. Now if you stop there, I'll be okay, but to be honest, square root of 4 is 2, so you should go one more step.
What happens to the negative?
Oh, I left the poor little negative out. Thank you. So I was about to say, to check your work, remember we did this, you plug cosine of 105 degrees, make sure you're in degrees, and then you plug this stuff in your calculator, and if I left the negative out, I could see, oh shit, I left the negative out. So it's not a bad idea to check to make sure. You're gonna always check your work on these. Okay, maybe. Okay. All right, so what we desperately need to get into this next idea. So now that we know inverse trig functions. So for example,
What were you saying about inverse trig function is like there's a right triangle on it?
yeah. So again, if I have inverse secant of 8 over 5, this is an angle, correct? The output for an inverse trig is an angle. It lives in a triangle that I know stuff about because this is related to secant.
Okay,
So which side is going to be 8? Which side is going to be 5?
5 would be hypotenuse.
No,
Wait.
8.
it's secant. So it's 1 over cosine.
Oh.
So hypotenuse is going to be 8.
Bottom 2 is 5.
Say again, sorry.
Bottom X.
Bottom? Okay, the x side is going to be 5. Cool. So any inverse trig question, you could always set up a right triangle. When is it useful if I ask you, like, what's the tangent of this? Now that question's easy. I just have to get one more side and I'm done. Is that all right? So an inverse trig is an angle because the original trig needs an angle input. Yes?
Why is
So what would I do to find the angle? So if I didn't have that tangent over there, and it was just.
Oh, so if it's asking you to find the angle is, you got to plug it in your calculator. Now, if you look at your calculator, do you have an inverse secant button?
no?
So the question was, what is the inverse secant of 8/5? I don't have an inverse secant button. What kind of inverses do I have? I have an inverse sine, inverse cosine, inverse tangent.
Cosine.
So help me out. If the secant of the angle is 8 over 5, what is the cosine of the angle? 5 over 8. That I can put into my calculator, and it's the same answer as this because these both reference the same angle. So it's still an idea of reciprocate. It's just that we know we reciprocate the ratio of the sides, and the ratio of the sides is now inside. So if I want to change from secant to cosine, I've got to reciprocate the inside. So that's how I do inverse cotangent, inverse secant. I don't have those, so I just flip the inside, and then I can do their associated trig functions. Okay, maybe. I like it. Hey, Mikey. Okay. All right. So what we're getting into today is something we sort of took baby steps into before. So let me get it started. If I said I want us to solve this equation,
What section is this?
9/5. So I do apologize. You always have to ask because I just know ideas. I don't remember to say where they are. Can anyone tell me one answer to this? And I'll say how I want it rated. Say again? 5 or 3. Does everybody agree? Because that's where sine likes it. 60 degrees is it likes it. Why is that not the only answer?
Because
I'll take two of the answers to this. Why is that not the only answer?
it also falls in the fourth quadrant.
Where else is sine positive?
Yeah.
Second quadrant, because that's where y is positive, correct? Sine likes y. Good man. Okay. Much more helpful than Sokotal. So there's at least one more answer, right? What is that other answer?
No, I learned more not tutors. I learned all students take calculus. You put each quadrant off.
Sure, if that helps, great.
So it helps me.
I'm not the biggest fan of mnemonic like that, because it makes it sound like I need this because it's too hard otherwise.
That's what I mean.
But yeah,
Like, you know what I mean? All are
totally.
positive.
Now on this one, where else is sine positive? Second quadrant, so what's the other angle within one cycle? What's the other angle that works for this? We do it like
what's
this.
it called?
So 3 pi over 3?
That would be pi, so good.
No.
So everything that has a reference angle of pi over 3, where sine is positive, would work, yes?
2 pi over 3.
What is it?
2 pi over
2 pi over 3. All right, let me stop a minute. You guys all with me? In fact, the students that don't draw little rough sketches for themselves don't make sense to me. You want to draw a rough little sketch for yourself. You know y's got to be positive. Visually, then you know the quadrants you're in. The first quadrant, the second quadrant. You guys with me? The first answer you get will be the first quadrant answer. It will be the reference angle in any other quadrant that works. Because that's how reference angles work. Can somebody tell me now why that's not all the answers? How far does sine go? Forever. It doesn't just keep repeating the same stuff over and over. So how many angles should I get for the answer? How many angles make sine rad 3 over 2? Infinite number. I love it. I can tell some of you guys are like, if I don't say it, maybe I don't have to worry about it. Because I'm not going to write an infinite number of numbers. I'm going to capture all the answers. So help me out. All right. I need this.
I was gonna say, it's on the
Makes sense.
interval.
Guys, look. One answer. Let me make this really big. One answer is pi over 3, yes? And the other answer is 2 pi over 3.
Yeah.
Let me ask you, could I get from here to here and then back to here using the same size steps? Does that make sense? How far apart are these two? Pi over 3. And then if I want to go all the way around to here, isn't that a way bigger step? Okay. That's going to become more apparent here in a minute. If this is an answer, just look at this. If this is one answer, what's another answer that ends up in the same location? What would I do to get one more answer that ends up in the same location?
Add 2 pi?
Add 2 pi. Kick ass. Couldn't I add any multiple of 2 pi? I can't remember this book. I think this book uses a K. Couldn't I add any multiple of 2 pi? Couldn't I rotate once? That would be add 2 pi. Couldn't I rotate again? That would be add 2 pi's. Can I rotate again? Yes?
all the way around, yeah.
Yeah, totally. That's what this is doing, Kat. Yeah, right. If I add, so what's K? K is just, we normally say K is an
How
integer.
many rotations?
It's how many rotations. Normally we say it's an integer, which means it could be negative. But what I like to do anyway is to do plus or minus, just to make it really in your face that we're going forward and backward. We've known this. How do I get every coterminal angle to 10 degrees? You can list a few, but how do I get every one of them? But that would just give me 2 more. How do I get all of them? I don't just add 360, I add any multiple of 360, right? That's all we're doing. That is exactly what we're doing. We're just adding a multiple of 360 degrees. It's just radians. So if I do one full rotation, I of course get right back to the angle I was. Of course it's going to make the answer to this the same. Because it's the same stupid angle. Yes? I just keep going. So when I say plus or minus 2 pi k, that means go forward as many rotations as you want to, and go backward as many rotations as you want to. The answer is still the same. Yes?
So essentially it's boiling down to, here's the angle, this is the answer, and then if you go around it as many times, it's still the answer.
Yes. So the clue, the key to this is find all the answers from 0 to 2 pi, and then just add all the rotations on top of those. Yeah. So of course, what do I do here? Same thing, because I can rotate, so I just do plus or minus 2 pi k. There's all the answers. So your first step has to be relatively simple. It's, oh man, wait. I'm gonna give you guys a practice test. I love people that just leave. Very fast. Yeah. So, this is, remember doing, here, watch this. We did this the other day. I plotted in here sine x, but I also plotted the square root of 3 divided by 2. And we talked about how, turn off these stat plots. There we go. Oh, Jeebus, now I'm in. Whenever this happens, you're in the wrong mode. Okay, here we go. So we talked about this the other day. So of course, now that red line's going to come in, and the answer is everywhere that red line intersects. We only see a few, but of course that goes forever. So of course the answer to this, the answers to this will be infinite, because there's an infinite number of places where this fits that, where the output is this. Okay. So here, you guys try this one. Cosine theta equals negative 1/2. Where'd those go?
Okay, so
There.
that's gonna be like,
Yeah. I guess it's okay. Yeah. So you can always find
be
the
in the
basic
third
answers.
quadrant.
All right, so one answer is going to be where now? Careful. Where's cosine negative? Third and,
It's gonna
Second.
be like 60 degrees.
okay. What's that in radians?
Well, the reference is 60.
True. What's that in radians? 5 or 3. That's the reference angle. So give me one of the angles. What's this? You just did it. What is that one? Say again?
2 pi
2 pi over 3. And what's this one? 4 pi over 3. Kick ass. Of course, all I do is to each one of them, what do I do?
Add 2 pi or k.
Yeah, and what is this 2 pi k? What is the only reason that's there? What's the reason that's there is just to capture all the coterminal angles, all the rotations you could do forever. So it's like the last thing you worry about is tacking that sucker on. Okay, Barbara.
And it's saying 2 pi as in a full rotation, right?
Yep, 2 pi is a full rotation. Yeah, so we all know from day one of trig, If you make one full rotation, you end up right back to where you were. So of course, whatever angle you end up at is going to have the same cosine because it's going to make the same triangle there. Okay. So let's see a problem where I can do something more nifty here. I want to make this point. There is no way in hell to take a step and capture these, take another step and capture those, and take a step. The step size would be different. I can't take the same. So let's see what the hell I'm talking about. Whatever this problem. Sine squared theta equals 1/2. This was a little tiny bit tricky.
Sine squared.
Totally. So what do I have to do first?
Break down the sine squared.
How do you mean break down?
Oh, we do the angle, we do the.
No. Don't overthink it. Don't overthink it. Square root. Yeah.
Oh,
Don't I wish the square wasn't there? So don't bring identities in unless you really have to. This is just straight up take a square root. Now when I take a square root, what do I have to put? Plus or minus. So I'll do this side. Oh boy. Okay. What do you get on this side? What's the square root of 1?
1.
Square root of 2. And then what do I do with that? Plus. So what angles? Is everybody with me on that part? So how do you solve equations? Don't you undo what's being done to the variable? So the first thing I want to do is kill that square. So I took a square root. Fantastic. What angle makes sine rad 2 over 2?
45.
Good. Radians.
Or
Pi over 4. But I'm allowed to be plus or minus, yes?
or second quadrant.
So what quadrant could I be in
Or
to make sine positive or negative?
or to, sine positive or negative.
Wait,
It could be positive or negative, right? So every 45, every pi over 4 reference angle, those will be positive.
It can be in every one, yeah.
Those will be,
Those are
Negative. I'm sorry, what am I doing? Thinking negative as I say it. Yes?
How'd you get sine theta equals plus or minus square root 2 over 2?
Oh, that was when you just have to rationalize.
Oh, okay.
Yeah, just to put it in a form we're more used to. So watch this. I need you to understand. I could write pi over 4, and then I would get 3 pi over 4, and then I could put plus or minus 2 pi k. Screw all that shit. I don't need to do all that. I don't have to write 4 freaking things. Do you understand I have 4 base angles? 4 angles that live in one rotation? So I could do the same thing we just did. I could write all of them and then put plus or minus 2 pi k on each one of them. That would be okay. It would not be good. Because how far apart are these two?
Oh, they're
90 degrees. How far apart are these two? How far? All right, 90. So can't I write pi over 4, and if I take the same step, don't I continue to pick up the next answer, the next answer, the next answer? So instead of going a full rotation around to pick this guy up and then having to write a whole other thing for this guy to go forward, I'm just going to go this guy plus or minus
Pi
some
over
multiple
2K.
of pi over 2.
Pi over 2k. Or pi k over 2 there.
So why couldn't I do that here? Because the step size wasn't the same. Why? I can't capture all the answers by taking the same step. Here, everything is separated by 90 degrees. I can capture every answer by taking steps of 90 degrees, or pi over 2. So the first part cannot be, well, shouldn't be as horrible, because you should eventually get to a point where it's just an angle that you know. You know what makes rad 2 over 2. Right? The hard part will sometimes be how to write the freaking answer. Real quick, remind me, what's another reason why this makes sense? Because what's the period of cosine? 2 pi. This was a lucky situation. that I just happened to get angles that perfectly matched up, so I didn't have to write 2 pi. I could just take pi over 2 steps. I just got lucky.
So is it always gonna work with 45-degree angle?
Not always. If I only had these two and not those two, then I can't do the same thing, yeah?
Oh, because it would just be.
Because then this would be way smaller than this, so I couldn't capture everything with the same steps. Yeah.
It has to be plus or minus.
Well, it has to be the same steps to capture each thing.
No, yeah, but never mind, it makes
Okay.
sense in my head.
Okay. So what about, let's try this. What about tangent? So then I got to think a little bit. Where is tangent square root of 3? And the way I always remember is tangent goes like sine. So what could tangent be? The output to tangent could be rad 3, or it could be rad 3 over 3. Sorry, rad 3 over 1 there. Rad 3 over 3, or it could be 1, right? Or it could be 0 or undefined. Yes?
Correct.
Good. So one good thing for a student to know about trig is what are the possible outputs? So why was the last problem we did so easy, the rad 2 over 2? Because that was one of the possible outputs, so I should be able to think backwards to the angle. So what are the possible outputs for tangent? Rad 3 over 3. 1 kicks ass, because that's 45-degree angle, right? That's awesome. Or it could be 0, or it could be undefined. That's why it's got asymptotes. I don't have tangent memorized. When I wrote that down, I had to stop and think for a second, because I don't have it memorized. I just remember tangent goes like sine. When sine is big, tangent's big. So rad 3 is the biggest output except one that tangent could be. Well, not except one. Tangent is the biggest. Rad 3 is the biggest output I could have in the middle angle. So it's got to be 60 degrees. It's got to be pi over 3. Because tangent's big when sine is big. I don't know why I keep making pi over 3 angles, but too bad.
And
So one answer is pi over 3. Where else is tangent positive? Third quadrant. Notice how far apart these are.
Pi.
180 degrees.
So couldn't I capture this answer, and now this would make complete sense what we're about to do. So if I just add and subtract a half rotation.
Pi k?
Par k? Yeah, pi k, yes. And why does that make sense? Because what's the period of tangent?
Pi?
Pi. Period of tangent is pi. So it kind of makes sense that sine and cosine will most often have 2 pi there. Tangent will most often have pi there. Maybe. Alright, so let's look at a little more involved problem. What you got, Jeff? Let's do. Now, if you think about it, can you think about it for a second? Don't even write it down. Why would you not want to take a square root?
Then you wind up with a square root.
Square root of a sine. It's like, that didn't make that better. So, what do I do? Can I divide by sine?
Yeah.
Am I allowed to divide by 0? Can I divide by 0?
No.
Could sine be 0?
Yes.
So am I allowed to divide by sine?
If sine is not equal
Nope,
to
can't
0.
divide by sine because it could be 0.
Well, you just put that like a comment, I forget what you call it, it's like, you stipulate that sine is not equal
Oh,
to
yeah,
0.
you totally could, but that's a little bit beyond. Let's do this first, and then I'll point out maybe there's a shortcut kind of way to do this. But if I want to solve this equation, I can't divide by x. So what do? I subtract x, and then I factor, yes? And then I get my 2 answers. 0 and 1, blah, 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 blah. Okay. So what do I do here? Same thing. You can do it, Jeff. What comes out of these two?
Sine.
Sine. And what's left?
Sine minus 1.
Good. And again, what did I do here? Once I get a factor to say either this is 0 or this is 0. So what are my two things that I have to solve? Either,
Sine theta equals 0. And sine theta minus 1 equals 0.
so where's sine 0?
At the
On the x-axis.
Good. And how far apart are those answers? So if it's 0
Pi
radians, they're pi apart. So then I can just say 0 plus or minus
Pi k.
pi k, because they're pi apart. And where's sine theta equal to 1? There's only one place in the basic stuff, right?
Y.
Which is what angle?
North.
1/2.
Pi over 2.
Yeah,
And so, see how there's only one answer here? Because there's nowhere else here in the basic 1 cycle that it becomes 1. So how far do I have to go to get the next answer?
Plus or minus pi k.
No. If I go pi, I'll go here, and that's negative 1.
2 pi.
Ah. Shaboo, shaboo. So in some of these problems, there could be some factoring happening. Okay. All right. Here's the last level to this. So what if I had cosine 3 theta equals negative square root of 3 over 2?
We separate cosine 2 theta plus theta.
Desperately don't want to do that.
So no identities.
There could be some identities I want to use. I don't want to use that identity, and I'll show you why. You could. You totally could. And then you end up with an equation that is disgusting. And I don't blame you for thinking you should, because I've been pushing identities hard.
Like a double F.
But this problem, can we figure out what this angle is? Yes. Can anyone tell me, what do I take the cosine of to get negative rad 3 over 2? What quadrants could I be in? 2 and 3. Because that's where cosine's negative, yes? And what would that reference angle be to make it rad 3 over 2?
3.
Yeah, so pi over
3.
6.
You guys with me so far? So we're sort of pretending like we didn't even see the 3. Like 3 theta is just an angle. 3 times theta is an angle, yes? So I'm going to solve for it first, and then I'm just going to divide by 3. So what could this angle be? What's this here?
180. No, sorry.
150.
150.
Oh, we're in radians, guys.
5
Yeah.
times.
Thank you. And of course I would put plus or minus. Plus or minus. Wee. Thank you.
Then you divide by 3.
And then what could 3 theta also be? What's this one?
7 pi over 6. No, wait.
Oh, sorry, which is it?
7.
7, yeah. So at least a 10. So what? Now, real quick. Do you see how you pretend as if this is just one big ass angle? So you treat it just like we did the earlier ones when there wasn't a 3 here. But I know I'm not done yet because I haven't solved for theta yet. So like I said earlier, like Philip just said, all I'm going to do is, how do I solve this for theta? Divide by 3. And how do you divide a fraction by 3? You just put a 3 on the bottom of it.
5 pi over 18.
Good. 5 pi over 18. Plus or minus 2 pi k over 3.
7 pi over 18.
Theta equals 7 pi over 18. Give or take 2 pi k over 3. Very freaky. Real quick, can somebody tell me the period of this guy? What's K? So what's the period?
It would be 2 pi over 3.
2 pi over 3. So since the period's 2 pi over 3, it makes sense that I want to go 2 pi over 3 to get the next answer, 2 pi over 3 to get the next answer, because that's the period. That's when it keeps getting the same answer. Do you have to know that ahead of time? No, it's just something I want to point out. So, let me give you the practice test, and I'll say this while I'm doing it. Section 9.5, I'm not going to make homework due tomorrow. Thursday. So on the test, I'm going to put a bonus question from section 9.5. You still have to do 9.5 homework. It's just not going to be due yet. Right? I have this feeling, I can sense this from you guys. You're like, I cannot do another section, Jeff. You're a freaking God. So I will put a question. It will be on the bonus. So if you want to try to get ahead a little bit, try some problems out, you have a better shot at the bonus. So for example, number 4 on the practice test will not be on the test, not this test. It will be on the bonus, yes. Problem like that. Anytime. All right. So of course tomorrow, is this yours? Or is this? Oh. I'll have the answer key for this, and we'll review for the test. Test is Thursday still, as it has been for a while. Cool. All right. That's plenty. That's obviously, even if I wanted to do more, you could just head out. So if you have any questions, come and see me. Otherwise, I will see you tomorrow. I'll have these quizzes graded we did today.
So it's all 9.4, which has.
And remember, 9.4, I'm pretty sure I made that as credit. I believe. Yes, I did. Yeah. 9.4 is extra credit. Oh, it doesn't work that way. So whatever you make on the next test will take the place of the missing quiz grade. So it won't be a 0. It'll just be whatever that grade is. Yeah. Yeah, you'll be able to kind of make corrections, and I'll give you some points for that. Yeah. It's from 8.2 through 9.3, basically. Yeah.
So, just to clarify all the way, I know I could just look at the homework sheet, just up to 9.4.